statement in front of you, and I would like to have an answer that a large fraction of thermal energy is generated in the engine of a car, which is rejected to the air by the radiator through the circulating water. Should the radiator be analyzed as a closed system or an open system?
Close, sir.
Closed system, sir.
Some say as closed system. Those who are in the DL mode, they are saying it's a closed system. Closed system.
Yes, sir.
Who is this who's referring to it as a closed system?
Sir, Tariq,
Tarek, it's a closed system. All right. What's your good name? Saad. Saad is referring it to as a closed system. Abdullah. Closed system. What is it that is extracting the heat? Water. So if there is no water coming into the system, would the radiator be working? So if there is, you have one inlet and one outlet. If I have the inlet on the top and the outlet at the bottom, and water is not flowing into the system and coming out of the system, how can I extract the heat out of the system? If this is my radiator shown to you, sorry?
Suhaib, sir.
Sorry?
Suhaib, sir. Suhaib.
All right. So this system would be an open system because mass is crossing the boundary of the system. In order for the radiator to work, mass has to get into the system and come out of the system in order to extract the heat. Clear enough? I have another example. I have a can of, let's say, Pepsi or Coca-Cola, and I want to cool it down so that I place it within the refrigerator. Now, should I assume my can to be a closed system or an open system?
Closed systems.
Those were, sorry? Those who are in the online, open system or a closed system?
Closed system, sir.
So you would have a can of soft drink to be a closed system because whatever is to be cooled down is placed within this container and the container itself is closed. So there is no mass entering the system. The only thing that is taking place is the energy transfer through the boundary of the can. Clear enough? Is it clear? Moving on, we have density and specific gravity. Density is what? Mass per unit volume. Is there any relationship between temperature and pressure and density of a material? For gases, if we increase the pressure, the density would increase. And if we decrease the temperature, the density would increase. Or if we increase the temperature, the density would decrease. Clear enough? But for incompressible materials like solids and liquids, temperature and pressure are not that sensitive towards density. For instance, in liquids, the effect of change in pressure on density is negligible. Let's say I have water at 20 degrees centigrade at 1 atmospheric pressure. If I increase the pressure to 100 atmospheric, the change in density would be less than 0.5%. So if I increase the pressure for water at 20 degrees centigrade 100 times from 1 atmospheric to 100 atmospheric, the change in density value would be less than 0.5%, which is very negligible. Temperature, on the other hand, is slightly sensitive towards liquids. The same water at 20 degrees centigrade, if I increase the temperature to 75 degrees centigrade, the change in density would be roughly around 2.3%. Clear enough? All right. Now, known that density is expressed as mass per unit volume. And another property which is specific volume should be what? Volume per unit mass. So it is actually the intensity. Clear enough? Is it clear? All right. Another term that we have is specific weight, the weight of a unit volume of a substance. Again, the weight of a unit volume of a substance. And how do you define it? You define it with density multiplied by the gravitational force, the value of acceleration due to gravity. Does it make sense? Yes, no. If I have density value written on top, which is mass over volume, how can I convert the mass into weight? Multiplied by G. So essentially, mg divided by the volume would give me the weight per unit volume. Is it clear? इसमें किसी को doubt? Clear है? So density multiplied by gravity is essentially the specific weight. Another term that we'll see is the specific gravity. Specific gravity, as it is written over here, is the ratio of the density of a material with reference to any standard density. And the standard chosen is essentially the density of water at 4 degrees centigrade. Density of water at 4 degrees centigrade is 1 gram per centimeter cube. Clear? So if I have a table of gravity over here, which gives me specific gravities, various materials. Let's say I have gasoline. The specific gravity of gasoline is what? 0.7. What should be the density of gasoline? Very good. If I know that the density of water is 1 gram per centimeter cube, and I multiplied by the specific gravity, which is 0.7, essentially the density of my gasoline would essentially be 0.7. Another point that needs to be understood at this point is if I say that my specific gravity is 0.7 for gasoline, should gasoline be lighter than water or heavier than water? Density of water is 1 gram per centimeter cube, gasoline is 0.7 grams per centimeter cube. It is lighter than water, so it would essentially float on top of water. So all these specific gravities which are less than 1, they are essentially lighter than water and they tend to float on the surface of water. Clear? All right. Moving on, I have this example. The has a volume of 0.2 meters cube and it is filled with liquid water. The density of liquid water is given to be 1000 kg per meter cube. You have to determine the weight of the combined system. How would you do that? Any idea? How? कर दिया. Very good. So I have got this 203 kg. Good. What does the statement says? Determine the weight of the combined system. How would you find out the weight? Multiplied by 9.81. But the point to highlight over here is that if you have missed out this assumption, I'll not consider it correct. You have assumed that the value of G is 9.81. And based on that, you have found out the value of whatever 1991 newtons. In thermodynamics, very often you would see that there are certain assumptions associated with analysis. whenever you come across the analysis of a system and there are some standard assumptions associated with that system, you have to mention those assumptions before you could begin. All right? Clear enough? Now, what did the assumption do? It made my job easier. Similarly, when you are analyzing thermodynamic systems, you do assume certain things which makes your analysis rather easier, although it may not be 100% correct, but I may not need that. So, in order to perform an analysis, assumptions which can give you a fairly good result, you can have some assumptions, and those assumptions must be mentioned before you perform the analysis. Clear? Moving on, state and equilibrium. State basically defines the characteristics of the system. And equilibrium state is a state in which my characteristics of the system are not changing. What are the characteristics of the system? These are the characteristics which basically defines my system. And at equilibrium state, these characteristics are essentially not changing. Clear enough? All right. So thermodynamics deals with equilibrium states, and equilibrium is a state of balance. That means there is no driving force present within the system when the system is at equilibrium. And let's say these are two images shown to you, state 1 and state 2. What is the difference between state 1 and state 2? The volume has changed. The rest of the properties are the same, but the volume has changed. Since the volume has changed, my state has changed. All right. But in order to define an equilibrium state or thermodynamic equilibrium, there are 4 equilibrium criteria that must be met before you could say that your state or your system is in equilibrium. Those 4 criteria, the first criteria is the thermal equilibrium. That is, there is no temperature gradient within the system. For example, I have these two systems available with me. The one to the left shows 20 degrees, 30 degrees, 32 degrees, 35 degrees, 42 degrees within the same system. Is the system in equilibrium? Why? Can I say that my system is at 30 degrees? 32? 42? I cannot specifically say. However, on the other side, when I have a uniform temperature throughout my system, I can safely say that my system is in equilibrium and the equilibrium temperature is 32 degrees centigrade. Clear enough? So my system needs to be in thermal equilibrium before I could say that my system is having a stable state. The second equilibrium is the mechanical equilibrium. If there is no change in pressure at any point of the system, I could safely say that the pressure of my system is stable. Right now within this room, is there thermal equilibrium and mechanical equilibrium? Macroscopically. Clear? Pressure क्या है room में? Roughly 1 atmosphere. So my system is in equilibrium with respect to mechanical equilibrium. If I have not turned on the ACs, my system is in equilibrium in terms of thermal equilibrium. But as soon as I switch on the AC, the airspace which is just in the vicinity of the AC would have different temperature as compared to the corners of the room. So my system for the moment would not be in the thermal equilibrium. let's say after half an hour when all of the room achieves the same temperature, my system comes into thermal equilibrium. Clear? Now, the third kind of equilibrium is basically the phase equilibrium, which says that if a system involves two phases and when the mass of each phase reaches an equilibrium level, it stays there, you say it's a phase equilibrium. For instance, if you remember the phase, I'm in the liquid phase and I'm cooling down my material. You remember the phases were constantly changing. You entered into an austenite zone, then you entered into ferrite plus cementite zone. And once you reach to the room temperature, you have finally defined your final phases, whether it's a two-phase system, whether it's a eutectic system, but you have fixed phases at room temperature which are not changing. So that's the condition where you have phase equilibrium. Clear? The fourth kind of equilibrium is the chemical equilibrium, which says that the chemical composition of a system does not change with time and there is no chemical reaction occurring. If you remember, as you were cooling down from the liquid state, let's say 0.2% carbon iron, 0.2% carbon steel, you had two different phases or multiple phases that evolved, and the composition of every phase was changing with respect to the temperature you were studying at, until and unless you reach to the room temperature where you have the final composition of the fixed phases. That is the point of equilibrium. Is it clear? अगर सेम हो रहे हैं तो सिस्टम स्टेबल है. No chemical reaction means no chemical reaction means there is no net chemical reaction that is taking. All right, clear? All right. The state postulate. Now I need to define my system, and I want to say that this state is an equilibrium state. The state postulate says that the number of properties required to fix the state of a system is given by a state postulate. And what does the state postulate says? It says that the state of a simple compressible system is completely specified by two independent intensive properties. So we'll try to split this into uh, smaller parts. We'll try to split this state postulate into smaller parts. The first thing it says that simple compressible system. Now, most of the systems that you will be studying, or rather all of the systems that you'll be studying in Thermo 1 and Thermo 2 would be simple compressible systems. That means those systems would not have any effect of electrical field, mechanical field, magnetic field, the two major components that can affect a system: electrical strength that is being faced by that system, magnetic strength that is being faced by the system. They are not, I mean, they make a system more complicated. So a simple compressible system is a system which is free from the effect of electrical field or magnetic field. Clear? In that case, you need two variables. Which variables we'll see, but you'll have two properties that would be needed to define the state of a system. Clear? In case there is an effect of electrical strength, electrical field, or magnetic field, each field would have its own variable to fix the state of the system. All right. We have this room over here. Let's say we fix the state of the system by pressure in specific volume. Now, if there is no electrical field acting on the system, I would say, all right, I can define the state of the system. But if the electrical field is acting on the system, I need to have a third variable that would specify or that would fix the electrical strength, which is uh, acting on the system. Clear? The moment I change the electrical field or electrical strength acting on the system, my state would change. Clear? But for simple compressible systems, which you would be studying, you only need to have two variables. And what kind of variables? Two independent intensive properties. In order to say that my system is in equilibrium or my system is in a fixed state, I need to have two independent intensive properties. Now, you already know what intensive properties are. Can anybody recall what an intensive property is? I'll ask the one sitting. Is it correct? मास के इंडिपेंडेंट नहीं होता होता है मतलब मास से इंडिपेंडेंट होता है होता है नहीं होता those who are online इंटेंसिव प्रॉपर्टीज कौन सी होती हैं
जो मास डिपेंडेंट हो एक्सटेंसिव
जो
प्रॉपर्टी
मास
सर
के डिपेंडेंट हो हु इज दिस
सर एक्सटेंसिव प्रॉपर्टीज
इंटेंसिव प्रॉपर्टीज
कैन रिपीट
इंटेंसिव प्रॉपर्टीज कौन सी होती हैं
सो इंटेंसिव प्रॉपर्टी जो मास इंडिपेंडेंट हो
मास इंडिपेंडेंट हो कंफ्यूज क्लास मुझे भी कंफ्यूज कर दिए इंटेंसिव मेरे ख्याल से वो होती है जो मास के इंडिपेंडेंट होती हैं दैट आर नॉट इफेक्ट सो टू प्रॉपर्टीज दैट वुड be required to fix the state of the system are mass independent properties. Clear? Intensive properties, and then it says independent intensive properties. What is meant by independent intensive properties? Yes. Those properties, the answer was those which are not dependent upon each other. That means while I fix one property, I can change the other property. Temperature and pressure can be intensive independent properties as long as you have a single phase system. The moment you move towards a dual phase system, let's say we are referring to boiling. Boiling में क्या होता है? Liquid is transforming into the vapor phase. So you have two phases at the boiling temperature. Liquid भी एग्जिस्ट कर रहा है गैशियस फेज भी एग्जिस्ट आप 100 डिग्री सेंटीग्रेड जो है वो बॉइलिंग पॉइंट है वाटर का लेकिन कब है जब 1 एटमॉस्फेरिक प्रेशर होगा जो कि
Excuse me,
सी
sir.
लेवल पे होगा जी जी जी
सर हमारी स्क्रीन ब्लैंक हो गई है सर कुछ नजर ही नहीं आ रहा है
कोई बात नहीं मैंने यहाँ पे भी ब्लैंक की हुई है यू डोंट वरी आवाज तो आ रही है ना
ओके यस सर
ऑलराइट सो वाटर का बॉइलिंग टेम्परेचर 100 डिग्री सेंटीग्रेड है 1 एटमॉस्फेयर के ऊपर 1 एटमॉस्फेयर इज द सी लेवल और बॉइलिंग टेम्परेचर वो टेम्परेचर है जिसके ऊपर दो फेजेस को एग्जिस्ट कर रहे हैं if I take the same water to let's say Murray or Gilgit at a certain height from sea level where the pressure is very low boiling temperature 100 degrees जाएगा so you cannot boil water at 100 degrees centigrade you have to come down to a lower temperature in order to boil it now in that condition where you have two phases coexisting the independence that was there between pressure and temperature is no more there clear so you cannot refer to temperature and pressure as the two independent properties to fix the state of a system if it is a dual phase system this is a very important point this would come again and again अगर आपने सिस्टम की स्टेट फिक्स करनी है अपने सिस्टम को डिफाइन करना है और सिंगल स्टेट सिस्टम सिंगल फेज सिस्टम है temperature or pressure would be sub but in case you have dual phase system फेज ट्रांसफॉर्मेशन हो रही है और आपके केस में मोस्टली फेज ट्रांसफॉर्मेशन होगी लिक्विड टू द गैसियस फेज जो आप मेजरली फोकस करेंगे सॉलिड लिक्विड की आपने देख ली मटेरियल साइंस के अंदर. Thermodynamics with respect to mechanical engineering, you will be majorly focusing on transformation from liquid to gas. Within that phase, two properties, temperature and pressure, which are intensive properties, are not sufficient enough to fix the state of the system. Clear enough? You need to have either the third property or you need to have two independent intensive properties. Two independent intensive properties for that purpose, sorry, would be specific volume and temperature. Specific volume and temperature would be two independent intensive properties to define the state of your system. We'll discuss more on this later on. Process and cycles, we'll start with this in the next class. All right.